Law of cosines is very similar to law of sines in that it allows us to find the missing sides or angles in a triangle. The patterns that we're going to be looking for to determine that it's law of cosines is the side angle side pattern and the side 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 pattern. So if we have a triangle and we'll call it ABC, remember the sides are lowercase letters across from the angle. Our law of cosines formula is c squared equals a squared plus b squared minus 2ab times the cosine of angle C. So this is an uppercase C over here. And the statement about the fact that the bookends must be matching means that whatever side C you have over here, the ending angle has to be the same letter. So there's lowercase c and uppercase C. Now remember, when we did law of sines, it doesn't mean that every single time you do this, the C and the A and the B are going to follow that order. We talked the other day about having a triangle that's called WYX, and of course that's not going to end up fitting into this pattern. So you have to adjust accordingly. Whatever side you have here has to match the angle that you have here. So we are going to use this in any triangle, right triangle or not, and we're going to use it to find the length of a given side when the other two sides and their included angle is known. So for instance, if we know this side, we know this side, and we know this angle, and this is what we're looking for. Or we're going to find the measure of an angle when we're given all three side lengths. So in this particular case, we would know this side, and this side, and perhaps we're looking for this angle. The one thing that you need to make sure that you're really careful of is that when you go through and you do this, this angle of X has to match up with this angle here, or this side across from it. So for question number 1, it says that we have triangle ABC, and in this, side A is 2, side B is 4, and measure of angle C is 60. They're asking for me to find side C in simplest radical form. So because of this, I have the side angle side set up. That's an indicator that I'm going to do law of cosines. Law of sines will not work. If you try to use law of sines on this, it will not work because we don't have enough information with sides and angles across from each other. So in this case, c squared equals, why c squared? Because that's the side I'm looking for. A squared plus b squared minus 2ab cosine c. The angle and the side across from each other are the ones that have to be the bookends. And I'm going to plug in what I know. So c squared equals 2 squared plus 4 squared minus 2 times 4 times cosine of 60. And this says in simplest radical form, so that's a hint to me that this cosine of 60 that I have over here, I don't want to put a decimal value for. I want to make sure I'm using the fraction and or the radical. So when I go through and solve, c squared equals 4 plus 16 minus 16 times the cosine of 60, 1/2, that comes from the special right triangle. So c squared equals 20 minus 8. So c squared equals 12. And in this case, when I go through and solve, I get that c is equal to plus or minus the square root of 12. And then I simplify that radical into 2 radical 3. I'm going to skip a couple of questions here and come back and do those in a second video. So number 2 is one of the ones that I'm skipping. I will come back. For the next page, question number 1, they're giving me a triangle again, so I'm going to go into this, draw that triangle so I can label everything. And they're looking for the measure of angle A. So if they're looking for the measure of angle A, that means that angle A and side A need to be the bookend in my formula. So I am using an a squared over here equals, and then I have to go through and use the other side lengths on the right-hand side. So this is going to be b squared plus c squared minus 2bc times the cosine of angle A. So I interchange the letters so that the a's are the bookends. Substitute in what I know, so I have 5 squared equals 2 squared plus 4 squared, whoops, minus 2 times 2 times 4 times the cosine of angle A. So this gives me 25 equals 4 plus 16 minus 16 cosine A. I combine like terms. So on this side, when I combine like terms, I'm combining these two. This is technically a variable term here, so I cannot combine that. So this is 25 equals 20 minus 16 cosine A. If visually you're trying to make sense of that, that's like you having 20 equals 20 minus 16x. Your next step would be to minus the 20 from both sides. And then divide by negative 16. So when I go through to solve now, I'm going to have cosine x equals negative 5/16. And I'm solving for x, so I'm going to do cos inverse, negative 5/16. And then I'm going to type that into my calculator, and I'm going to find out that this is, I guess I changed the x to an a, that's okay. This is 108.2099569, which rounded to the nearest degree is 108 degrees. Somewhere along the way here, I switched my angle A to an x, so these are technically really angle A's if we follow suit. The whole way through I had A's here. Doesn't change the answer any, but technically I should have kept that. I am skipping question number 2, but I will come back to it. Question number 3, though, I am going to do. So I have triangle ABC. A is 3, B is 5, and C equals 7. They tell me in this question that they want me to find the measure of the largest angle. So some of you may be spending some time deliberating over that largest angle. In this case, the largest angle is across from the biggest side. So this is the longest side. This is going to be the largest angle. So I'm going to put an X in here. And then I'm going to go through and solve. So in this, when I set up my formula, c squared equals a squared plus b squared minus 2ab cosine c. So this is 7 squared equals 3 squared plus 5 squared minus 2 times 3 times 5 times the cosine of, I'll put an x in here this time. So 49 equals 9 plus 25 minus 30 cosine x. And if there's a mistake in this problem, where we are right now is about where that mistake usually is. Only these two terms can be combined. This 30 is connected to the cosine x. That is a variable term. So this is 49 equals 34 minus 30 cosine x. I'm going to minus the 34 from both sides. Divide by negative 30. Which means then when I solve, I get x equals cosine inverse negative 1/2, which gives me x is equal to, type that on your calculator, 120 degrees. One more question I'm going to do in this first video on the second page. Question number 5. These are Common Core questions here. You can see they really try to incorporate a real-world example. So they say there's a campground and that campsite A and campsite B are situated where they are 80 meters apart. So in this case, I'm going to put an A here and a B here, and they are 80 meters apart. So I'm going to put an 80 on that. The camp office is 95 meters away from A, so I'll put an O here for office. And it is also 115 meters away from campsite B. It says when the ranger is standing in the office, what is the angle of separation between the two campsites? So that is their way of saying, if this is the office and the gentleman, the ranger, is standing here, when he looks between A and B, his angle in here is what we're looking for. So I'm going to put an X on that. When I set up this particular formula, I can write down the law of cosines using A's, O's, and B's, or I can just say to myself that I know that the side across from the angle has to start, the two other sides are squared and added, and then I subtract 2 times both of those numbers, and it's multiplied by the cosine of the angle, in this case x. So sometimes when I'm doing this, I don't even write down a formula. You can if you need to, but you don't have to every single time. So when I go back now and simplify this work, it's 6,400 equals 9025 plus 13225 minus 21,850 times the cosine of x. I'm going to solve like I had in the last couple, which means that I'm going to combine like terms on the right. So that's 22,250 minus 21,850 cosine x. I'm going to subtract this over, which will give me negative 15,850 equals negative 21,850 cosine x. I'm going to go through and solve, which means I'm dividing both sides by that negative 21,850. And I would do this on my calculator, because when I do it on my calculator, I can find out that when I reduce on the left, I end up with 317 over 437 equals cosine x. That makes it very easy for me to type that right into my calculator. So x is equal to cosine inverse 317 over 437, and I end up getting an x value when I type that in of 43 point blah blah blah. It does not say for me to round this answer, so that is my final answer on this particular question. I am going to do a second video for the questions that I skipped. It is not a mandatory video, but good practice for you. So if you want to try a couple of these on your own and go back and take a look at my answers, feel free.